The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. I am your host, Jamie GaProgMan Taylor. In this episode I talked with Paul Michaels about software architecture and how important it is to get the architecture right before writing any code. Paul has recently published a new book on the subject called Software Architecture by Example using C# and .NET, which covers CQRS, event sourcing, distributed systems, and distributed transactions, to name just a few. Along the way, we covered ubiquitous language, living documentation, and keeping a log of the rationale behind why you made the decisions that you did when building your applications, and how this can help other devs when they have the WTF moment whilst reading your code. After we'd finished recording, he passed along a discount code for his book. You can only get the discount code by heading to the show notes for the episode and scrolling to the bottom of the transcription. It will be listed in the useful links section. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So, first thing I'd like to say, Paul, is thank you ever so much for being on the show again, because this is his second appearance. My goodness, you're part of a very small elite group of people. I think there's only 5 or 6 people who've been on the show twice, and I think there's only 2 who've been on the show 3 times. So, you're getting there.
Well, thanks for having me. I do get to go watch if I've been on like 5 or 6 times or something.
I mean, maybe it might be a plastic one, but yeah, we can organize that. Oh my goodness. Okay. For the folks who've maybe not heard your previous episode or are new to you and the experience that is Paul, I was wondering, would you mind giving us a really quick sort of overview, maybe an elevator pitch about, the kind of work you do and all that kind of stuff?
Yeah, for sure. So I'm head of development at a company called Music Magpie at the minute. You might have heard of the company. They're in the what's known as the re-commerce space. So they sort of buy and sell stuff, various things, CDs, DVDs, phones, whatever you've got. And I'm also a Microsoft MVP, as are you, recently. I also, in my spare time, run an online group called Mini Hack, which is a sort of an online hackathon inside of 2 hours, which you've kindly come and judged for us on occasion. And I also write a blog when I'm not doing that. So that's pretty much me in about 5 sentences.
Fantastic. You're a fellow who cares about free time person then.
Yeah, exactly. Yeah.
Yeah. I do remember the mini hack that I judged. It was amazing. One of the teams took like a sound file, converted it to a bunch of numbers, then converted those numbers into Japanese, and then back again and got almost the original sound file out. It was amazing.
Yeah, we have. So I come up with these ideas that like I'll think we'll come up with a thing to get people to do X, and then we give it to them, and then nobody ever does X. So they always come up with something that's different, but in most cases better than I kind of anticipated, because it's just the weird and wonderful things, and because it's like it's not like if you get paid to sort of develop software, then somebody comes up to you and they say, well, I want you to write this software and it's got to, I don't know, sell widgets or whatever, so you've got to write software that sells widgets. At Miniac, you ain't got to do that. The brief is as vague as we can make it, and at the end of it, if you just come up with something that's just a laugh or a joke or whatever, everyone just laughs and jokes. It's not, nobody cares if you kind of don't make it. And half the time, people who do that win because of the fact that it's just like the funnest thing.
Yeah. Like I say, it was an absolute joy to watch because just listening to these teams talking about, oh, we'll do this and we'll do that. And then wasn't there one of the teams did something with color on that mini hack I was involved with, where they changed the sound into color, and then I can't remember, but it was all amazing was what it was.
I think it was there's some very strange things, and every time it's the same idea. So I think we've been trying for a while to get people to do, because I had this idea I was going to use like security, so I thought we'll do top 10. It took 2 or 3 attempts to get somebody to actually do security. Every other time it was like they were just kind of circumventing it and do stuff that was just fun. So in the end we were like, right, you've got to actually do something that's on the OWASP top 10. And even then we ended it with some very strange things. I think the guy that was judging it was he'd been on the board or something at the OWASP board, and he sort of one of the teams produced SQL injection attack, because we said, write something that's vulnerable. And he was like, oh, kudos for actually doing that, because these days it is not easy to write something that's SQL injection vulnerable, because you're basically fighting the software from every level. So, it's interesting. Yeah, it's interesting to run and interesting to watch.
Excellent. Yeah. So I mean, my personal experience, I think all the listeners should check it out because it is tons of fun. And like I said, all I did was watch, but yeah. And it is, like you said, it's getting people to exercise those creative muscles to just like, let's solve a silly problem in a silly way or whatever. It's brilliant. I like it. So yeah, let's talk. You see, you mentioned earlier on you got this new book out. Let's talk about this new book, right? Because last time you were on the show, you had a new book. This time, you got another new book. You're like an author extraordinaire over here. Let's talk about this.
Yeah,
all the words and arrange them in a pleasing manner.
Yeah. So when I was a kid, I always wanted to be an author, but I always wanted to write fiction books. So maybe one day I'll write a fiction book. But yeah, so I suppose the last couple of places that I've worked at has made me think quite a lot about architecture. And specifically with, I mean, I liked writing that first book, but one of the things I didn't like was the fact that it was when you're writing about software that doesn't exist yet, and at the time it was like, I think .NET Core 3.1 didn't exist at the time I was writing it. That is really frustrating, because you write a chapter and then you finish the chapter and the Microsoft have changed it, like not just changed it a bit, but everything has changed, like right from the ground up. So you got to delete the chapter and start again. So I liked writing the book, but I didn't like that because it was frustrating. So I said, if I write something else, then I'm going to do like a topic that doesn't have a time and date associated with it. So I thought I'll try and write something on architecture. And I had a look around, and I didn't see anything where there was a sort of a book that gave you some principles and then gave you some examples about how to use them. So I pitched it to A-Press, and they said, yeah, we're up for that. And then sort of started the journey. And it took, I think they were saying, can you sort of get it written in 6 months? And then when I finished laughing, I think it ended up taking taking around about 18 months in the end. But they were quite patient with me.
Awesome, yeah. I like, can you write a book in 6 months? I'm like, dude, I can't even write a Jira ticket in 6 months. What are you talking about?
No one can write a Jira ticket in any amount of time.
No, of course. So let's talk a little bit about like the stuff in the book then, right? Because like you said, like software architecture itself is like, it's not really pinned to a certain date or time or technology, right? So, I mean, so first of all, what's the technology in the book? Is it .NET? I guess it is, right?
Yeah, it is, because I'm not much of a, what's the term? Is it polyglot? I'm not much of a polyglot, so I kind of stick to the couple of languages that I'm familiar with, and given that one of the languages that I'm sort of vaguely familiar with is JavaScript, then obviously I'm going to stay away from that. You'll get a load of complaints from me saying that, but I can't deal with non-static languages anymore. Too old.
Look,
I've lost all my hair now.
The way I see it is, if it's not for you, it's not for you. You know what I mean? I'm not one of these who's like, you must write it in this language, or I'm gonna, and I try, there are other shows, shall we say, who spend a lot of time making fun of other languages, and I'm like, where does that get us? It doesn't get us anywhere. And secondly, all of your jokes are trite because you've already told them before. You know what I mean? So like, let's just move on, right? If somebody wants to write something in Python or JavaScript or Go or Rust or whatever, then let them.
Yeah,
what's the problem?
yeah, I agree. But anyway, so I stuck to .NET because it's what I know. So it's written in that. The interesting thing, I think we were talking about this before we started recording, was that if you stand still long enough in IT, then everything just kind of comes round. So it's quite interesting with software architecture, because the sort of stuff that was considered, in some cases used, in the 70s and 80s, has come round again and is now relevant again, because the reason that it wasn't relevant at the time is because of things that don't matter anymore. So if you take something like event sourcing, so the concept of you store everything that happens to a system since its inception. But if you went back, like, I don't know, 30 or 40 years and suggested that to one of the guys programming away in sort of, C or assembler or COBOL or whatever it was at the time, and his database and his hard drive that's got like 3 meg, and that's like the most that money can buy, and you said, we're going to store everything out, and we're not going to normalize anything, we're just going to store all the data, and since the time the system started, it'd go, oh, okay, and who's paying for it? Where are you getting these millions and billions of pounds or whatever? Where are you going to store all this in some kind of massive warehouse with hard drives? But obviously these days, hard drives hard drive space is incredibly cheap, and so that conversation changes. But it's the same. It's the same idea. Nothing's really changed. It's just that the sort of landscape that you're in is changed. So yeah, it's interesting to kind of think about that. There's stuff that was previously kind of discounted because of the constraints that existed. Those constraints have gone now. So we're in a different landscape, and you can go back, and so you can write an event source system, and you can store every event that's ever happened to that system since its inception. And it's a fascinating place to be, because when you do that, you end up with a whole new set of problems, and I mean, it gives you things like that give you a lot. But it's kind of a theme that I kept on coming back to when I was investigating architecture, that there's no free lunch. So every time you come up with something, a solution, whatever it is, you pay for it, and in some cases you pay quite a high price. So if you want to go down one of these routes, then make sure you know what the price you're paying is, because it can be prohibitively expensive in other ways.
Yeah, I do like the gaining that depth of that breadth of knowledge of different systems gives you the idea that the experience to actually go, this is not right for us, this is right for us, right? Because, like you said, the standard sort of CRUD app that everyone builds, right? Put something in the database, update the thing that's in the database, create a new thing in the database, get me the thing from the database, now delete it, right? Well, normally we'd use something like SQL with an SQL style database, maybe SQL Server, maybe MariaDB, maybe Postgres, something like that. And you store normalized data that's data partitioned across tables, and it has keys everywhere, and that's how it relates, like relational data. But sometimes that's not the right thing. And sometimes not storing all of these events is not the right thing, if that makes sense. Sometimes storing every single event that has ever happened to the system makes sense. Like maybe not for an e-commerce website, perhaps, or maybe not for a to-do, right? Storing everything in a to-do, storing every single event that happens in a to-do, probably not the greatest idea. But maybe e-commerce is great for this. Maybe re-commerce is great for this, right? Because you need to know who did what and when and how it changed the system, right?
Yeah, and it's I suppose the thing is that what you've just said is absolutely right. That it's the key is to not over-engineer, I suppose. So, if you're to do a solution, and that's the thing. Then it's in our business we provide solutions to problems, right? So if your problem is I need a way of listing the tasks that I've got to complete in a day, and the quickest and simplest answer to that is here's an A4 sheet of paper and a pen, then that's cost you like, I don't know, £3 or £4, and you're good to go. And the alternative is you spend 2 or 3 weeks writing an app that then it's got the problems that an app's got. You've got to pay for it to actually be produced, or maybe you've got to pay financially, maybe you've got to pay in time, whatever it is. Or if the fastest thing is a manual process, then go with the manual process, because half the time that the manual process kind of works. And I mean, one of the exercises that is sort of, I think it's quite useful to go through is when you're considering what it is, what requirements the customer's got, whoever that may be. If you sort of go through and say, well, how would I do this manually? What would it take? And at what point does that become infeasible to kind of continue to do it manually? So, if you've got a to-do app, you go, well, here's an A4 sheet of paper. How long does it take you? Write that out. 2 minutes. Okay, right, good. But we've got whatever it is, 500,000 people who all want to write a to-do app. Okay, now how long does it take you? Well, now it takes me 3 years. Okay, then you probably need a computer. I think that's an interesting and a good process to follow to sort of go through and sort of think it, maybe think it through in your head, or maybe actually sort of talk to a customer about what would you do if you had to solve this problem manually. For things like, just coming back to event sourcing. Event sourcing is it started as a manual system. I mean, accounting predates IT by thousands of years, and accounting is an event source system. You write down, this is what I sold on a piece of paper, and then you might keep a balance, but you write down each individual transaction. So yeah, it's I think that's quite a useful way of thinking about things, and not over engineering things is a bit of an art, I suppose.
Oh, totally. I was talking to someone just today actually about the fact that you can do conference-driven development, right? Where you go to, like, as we record right now, on the date of recording, NDC is happening, right? And it will be the first day of the talks are happening today, I guess, because they do like a couple of days of courses to begin with. And you can legitimately make a load of money by doing conference-driven development. And by that, I mean, you pay £3,000 to go to a conference. You furiously make loads of notes on things like CQRS and domain-driven design, and these are all great things, but then you shoehorn them into a solution that then takes 3 months longer than it should do. I'm not saying CQRS is bad. I'm not saying DDD is bad. They're actually quite good, and they solve very important problems. But sometimes like you say, the best solution is here's a piece of paper, here's a pen, or have you tried a spreadsheet, or let's just store all the data as a JSON blob in the database.
Yeah, and I suppose that's the thing. And if with a lot of these problems, if you need an event source system, you're probably going to know it. Like it's going to be something that, as you start thinking it through, it's going to be kind of these sort of things. Same with sort of microservices and so on, which are another one that are quite popular at the minute. If you need a microservice architecture, then you're going to be feeling the pain, and you'll know that you need it to solve that pain. If you're not feeling the pain, if you can, I can't remember. I think it was Dylan Beatty I saw do a talk once, and he said every system architecture is box cylinder. If your system works as box cylinder, do that. It's so much easier. It's just most of the time now, certainly with .NET, but I imagine with most modern things, file new and you've got your two boxes already, and you don't have to write a line of code. So 20 minutes of mouse clicking and you've got your box cylinder there. And if that works, do that. I mean, there's no point in writing a microservice architecture that's going to take you months and months and all the problems that brings with it. Not that at certain points they're not worth addressing, but most people don't have them problems.
Absolutely. I'm very much a case of solve the immediate problem, because then you'll find out that the problem isn't the problem, it's something else, right? I've often said that the customer, client, user, whoever, doesn't know what they want till you give them what they don't want. And I feel like too much work could be spent on engineering the most elegant possible solution using all of the principles that people take to be laws, but principles. You must do it like this. Well, actually, it's more of a suggestion. I'm not saying Solid is wrong. I'm not saying Cupid is better. I'm not saying don't program to interfaces, but sometimes, it's like which will solve the problem faster, right? Spending weeks, or rather maybe spending days building interfaces to interfaces to interfaces on the off chance that you swap something out, or using new to glue your system together because you need to get it out the door today. Which is gonna solve the problem, right?
Yeah, and obviously there's considerations around that, and I suppose it's a bit different if you sort of messing about in your bedroom as opposed to actually going and getting paid for doing some of these things. But I saw a talk recently that sort of similar sort of vein on I think it was ThoughtWorks. They were saying that using SPA frameworks by default is something that you should be very wary of doing. So if a server side rendered ASP.NET MVC app works, use that. Don't be messing about with React unless you need React for a reason. I like React. It's one of it's a nice client side framework, but it's not free to use. It comes with complexities, and you sort of introduce a load of problems that you've then got to solve, and at some point I think it's worth backing off and going, oh, hang on. But have I actually created this problem for myself? Did I need to?
Yeah, and I suppose the same could be said about using ASP.NET or using Django in Python or using whatever Go uses, right? You need to weigh up the pros and cons, right? You need to think, how long is it legitimately going to take me to build this? Not back of the envelope style conversation, but like, how long will it take for me to build this system? And how much investment does that represent? And then how much support, right? Because I think it's amazing that people use brand new technology as soon as it comes out to build a real life product. But then what do you do when it changes, right?
with JavaScript, you get that there's like 3 or 4 libraries a day that get created.
Yeah, just in the time we've been talking, there's been 1,000 new JavaScript libraries created, then destroyed.
Yeah.
But yeah, now that we've finished sort of making fun of all the other architects out there who are making things a little bit too complex, so what I really like about event sourcing, right, is that idea that you can literally rewind through time, right? Because it represents all of the changes that were made to the system since day zero. You can actually, like an accountant can, right? They can look back through their log of what has changed, and they can say, right, I can see where I've made the mistake. I carried a 1 here, or I've put too many decimal points in or something. And then, you just fix that one thing, and then magically everything else sort of, flutters into existence, and everything sort of just fixes itself. But what are the, like, so is the book just event sourcing, or are there other things going on in there?
No, so I mean, I've covered a few other, but basically, it's a list of problems. Like we just talked about the to do problem, which is a well known and well solved problem. Everybody needs a to do app, and and everybody's written one. But it covers. I'm sort of interested in some of the other sort of ways of solving problems. So I think what I've done each chapter is I've said, well, here's a specific. I'm going to use quotes here, but nobody can see it outside of you. So for anyone listening, I've just done the universal sign for inverted commas. Basically, it's a problem that for every chapter. So I've made up a problem for every chapter, and one of them, one of the interesting ones was a travel sort of travel app, if you like, because one of the things that I was interested in was how travel agents or anyone who has to sort of deal with third parties, but in a single transaction, kind of manages it. So I investigated the idea of a sort of multi-step or multi-phase distributed transaction. So effectively, the idea, if you've ever been on Expedia or you've been on these kind of companies where you'll say, I want whatever it is, a hotel, a plane, a car, and it goes off and it goes, okay, I booked your hotel, plane, and a car. It goes, I can't get the hotel, plane, and car at this time. What it doesn't do is it don't come back and go, I've got you the car, but you can't have the hotel or plane. Because obviously, there's no point in that. So, and it's interesting when you look at the sort of way to do that in technology. It's very difficult because obviously, if you're transaction on a database, if you're on your local database, you can have an ACID transaction, because you can say, I'm going to sort of stage this entire set of changes to the database, and then either they go through or they don't go through. Obviously, you can't do that if you've got to go to one system and say, okay, make this change, and then go to another system and say, make this change, and the second system says, well, I can't make that change. Now what do you do? Because it's not like you can go back. So I sort of investigate ways that you can get around that. I mean, essentially, there's the ways that you get around it are you either persuade the people who you're interfacing with to allow you to sort of stage the transaction in a sort of traditional distributed transaction, or you basically book it and then cancel it afterwards. But it's I found the whole thing interesting, and the solution that I came up with, I ended up using Service Bus as a transaction coordinator, which I don't know how useful that'd be in a sort of real life scenario, but it was pretty cool to write the proof of concept.
If you're enjoying this show, would you mind sharing it with a friend or colleague? Check out Podcatcher for a link to the show notes, which has an embedded player within it and a transcription and all that stuff, and share that link with them. I'd really appreciate it if you could indeed share the show. But if you'd like a few other ways to support it, you could leave a rating or review on your podcatcher of choice. So if you head over to .netcore.show/review, you'll find loads of ways to do that. You could consider buying the show a coffee. The Buy Me a Coffee link is available on each show's show notes page on the website. This is a one-off financial support option. You could become a patron. This is a monthly subscription-based financial support option, and the link to that is included on each episode show notes page as well. I'd love it if you could share the show with a friend or colleague, or leave a rating or review. The other options are completely up to you, and are not required at all to continue enjoying the show. Anyway, let's get back to it. I like it. You see that? That seems like it's a non-trivial, like you said, it's a non-trivial problem to solve, right? You got these 3 separate services, and you can book or buy or purchase or whatever, something from each of them, but each one of those requires the other one to go through. And that is not something you can, like you said, it's not something you could do in ACID, right? You can't, it's not even like it's sharding the same database because you're talking to different ones, right? That's just, like, part of me is going, how in the heck would I do that?
And but you get similar sort of so when you go to like a sort of what you call an event-driven architecture, I suppose, or microservice, whatever, however you want to sort of phrase it. It's a similar sort of process, and it's if you're storing your state across multiple points in your system, you've got to deal with the fact that at some point you're gonna have a difference, and you might say the system's going to eventually catch up and sort of be consistent across, but you might not be able to guarantee that, and so you've got to come up with a strategy of, well, how do you deal with that? How do you deal with the fact that this database is X and the other database is Y? But is it X or is it Y, and how do I know which? In some cases it might not matter, and in fact in most cases it probably doesn't. But if you're writing a system to manage a nuclear power plant or sending a rocket to the moon or something, then it probably does matter really, really badly.
Yeah. And I think that's the difference, right? There is and I don't wish to upset any travel agents who are listening or people who are planning on going on holiday. There's almost like a scale of importance, right? If you are writing an event-driven system for a nuclear power plant, or for an airplane, or for a rocket going to the moon or something, then consistency really, really matters. But I feel like there must be some like acceptable tolerance for travel agents or whatever. And again, I'm not making fun of those folks or the people who build those systems. I'm just like, you have to have some kind of tolerance, right? Otherwise, you're going to spend your life pulling what's left of your hair out, going, why is it that it just doesn't work?
Yeah, it is fairly tolerant, and I suspect that there's very few nuclear power plants that have distributed systems. I think most of them are probably written in like VB6 or something.
Maybe. So okay then. So sorry.
I was just going to say, I'm sure I heard, I can't remember where I heard it, but somewhere in America there was and I don't think it was a nuclear power plant, but I think it might have been a water treatment plant or something. And they got hacked, and the way that they got hacked was they had one of the controller machines sat on with a log me in or something like that, and a weak password. And the only way they spotted it was they saw the mouse moving across the screen.
Oh, right.
Found that. I can't remember where I heard about it, but it might have been .NET Rocks or something like that. But yeah, it was. It just surprised me a little bit. But apparently, it's it was a. I don't know why, because I don't really understand about water treatment plants. But there's some chemicals you can put in the water that would poison the supply, and these are on dials on this machine, so it's it's apparently a dangerous problem that they had. But yeah, it just reminded me when we're talking about like.
So what you're saying is working from home is not always the best solution.
Well, not if the keys to the kingdom are a machine in the office, and the only way of stopping people breaking in is watching it.
Oh my goodness! I've been on a real security kick for the last like 5-6 years, just learning about like app security, development security, and there's this wonderful story. If you allow me to sort of go off in this little tangent for a little minute, Terry Pratchett wrote in one of his, I think it's a book called Slip of the Keyboard, which is a collection of some of his sort of newspaper articles from before he was an author, when he was a journalist. And he said the great thing about nuclear power plants is they're incredibly secure. Right up until you hire John the electrician, who needs to run a wire from this room into the next room. And rather than running a wire out the door, round the corner, and back in through the other room, he drills a hole through the wall that passes the wire through, not realizing that that wall is there to protect any radiation getting out of that room. It's a wonderful like allegory for any kind of security ever, right? You can build the most secure system possible, but the problem is that if you build it securely, then it's inconvenient for the users of the system. If it's a software system, if it's a building, if it's whatever, right? The more secure it is, the less convenient it will be, right? Think of like every time you go into a building and you've got a fob or a card you've got to bip against a sensor, or you've got to type in a PIN number to open each door, right? If you forget your fob or your PIN number, that's horribly inconvenient, right? Because then you've got to explain to your boss, you've got to let me in, I've forgotten my fob or whatever. So then people invent ways of getting around it. People will hold the door open. People will put a brick in the way of the door so it doesn't close, right? Because they're sick and tired of hearing about Dave, the engineer, who keeps forgetting his password or whatever. And so some of the world's greatest security has always been beaten by some of the most low level of not even a hack. It's just like, this just makes it easier for me to do this, right?
Yep.
But, just reminded me.
Yeah, and I might seek that out by Terry Pratchett. I've got I need to reread some Terry Pratchett actually.
Yeah. Well, I'm a big fan, and I don't keep it quiet that I'm a big fan. But yeah, Slip of the Keyboard, that's his journalism stuff, and that's where that story exists. I forget which story it is, but it's one of them, and it's really good. But yeah. Okay, so we've talked about distributed transactions, we've talked about event sourcing, which leads us slightly into event-driven architecture, right? So, let's say I'm used to doing single CRUD apps, and I've got maybe a monolith. It's an N-tier monolith. I click a button, it goes, passes a message to a service talks to the database, message goes into the database, we're done, right? Get me this thing out of it. It goes user interface, service, database interface, brilliant, not a problem. That's not event-driven, is it? Because like event-driven is like, I want a thing, go get me the thing, and I'll happily wait here until you've got the thing, right?
Yeah, essentially. So what we're the problem that I think you're trying to solve with when you sort of implement something like that is trying to make something horizontally scalable. So if you've got your sort of CRUD app that you've just described, that's probably fine. And if you've got 10, 15, 100 people using that, it's probably fine. When you get into massive scale, then you've got to have a way of essentially, because obviously your bottleneck there is your database or it's your service. It probably ends up being your database. At some point, there's one of them things at a bottleneck. So if you can replicate the service and the database that people are using, then you can obviously increase the number of people who are using it. So basically, that the way that people tend to do that, or the way that has been done, is that when logic travels through a system, you just bung a message somewhere, and you say the next thing that needs to happen is this, this next thing, or probably do it the other way. You'd probably say, I've just done X, I've just done Y, and then the next thing kind of picks it up itself. But yeah, the advantage you get is sort of scalability. The obvious disadvantage that you get there is complexity. So it's a massive trade-off that you pay. If you're going from a simple single database and a simple service that calls that database, and you go to a system where you've got several databases and many services and a sort of message broker in the middle, you've just increased the complexity of your system by 100-fold, and slowed it down a little bit, probably, because obviously it's a lot faster to just deal with a single message and send back the data somebody's asked for, instead of sort of sending it around a distributed system and then return it. So yeah, I mean, again, it's a fascinating architectural sort of mechanism, but and in some cases it can be. So you don't have to, obviously with these things, you don't have to take everything. You don't have to sort of read the various books by the people who sort of suggest these things and then take everything they say. What you can do is you can pick and choose. So you might decide that actually what I need is not a sort of horizontally scaled system. What I actually need is some way to stop my existing system from crashing. So maybe all I need is a message queue, or maybe I just need to slow people down. So maybe you can, I think Cloudflare do like a waiting room now. In fact, I saw that at the I actually went to the Grand National this year, and when I tried to get onto my my bookie site, after a bit it started showing me the Cloudflare waiting room thing to say you can't get in. But that's if that solves your problem, then that's probably a hell of a lot cheaper than messing about with introducing a message broker and so on. I suppose it's starting to sound like I'm talking down all these architectures and saying that they're not necessary, and they are necessary, but they're not always necessary for everything.
That's the key thing, yeah. It's like what's that thing that Hanselman always says? When all you've got is a hammer, everything looks like a nail. And so if you only ever do event-driven architectures, then all you'll ever build, like you'll make to do the event-driven architecture, right? You'll have a to-do app which talks to a message queue, which has a dead letter queue and an active and an inactive queue, and like a sharded database. And have you ever seen that there's a Java repo, and it's brilliant. It's Enterprise Hello World, and it's like 50,000 lines of code just to print Hello World on screen. Like that's the kind of thing I mean, right? You over-engineer your application, but then there are times when that fits.
Yeah, and there's times when it's definitely necessary. I suppose one of the things that I suppose it's worth mentioning is the sort of concept of a minimum viable product, and what that means. I suppose the thing about that is, if you've got a set of requirements and these are the things that you need in order to run your business or whatever it is, that's what you would call your sort of minimum viable product. Once you've satisfied all of those criteria, what you're saying is you can now sort of essentially run your business or do your thing based on the system that you've got. So anything you do on top of that is not necessary for you to run your business. So there is a question of why you're doing it, because every time you change, and again, this is something that I suppose people forget. Every time you change a piece of code, that's risky. Like I call it code churn. It's risky, so it doesn't matter how good a programmer you are. You're gonna make a mistake at some point. So every time you change a line of code, by definition, you're changing the behavior of the system. And unless like some absolute god of programming, and even then, in fact, probably mostly then, you're going to make a mistake. You're going to not see something. You're going to not realize something. And at some point, something's going to break. So once you've got your MVP, if you're still changing your system, then you should consider what the benefit of that is versus the risk, because there is a risk to breaking things that are currently working. So if you're just changing it for the sake of it, and certainly if you're ripping out a framework and putting another framework in, and at the end of it the functionality is going to be exactly the same because it's a newer framework or whatever it is, or then you've got to ask yourself why you're doing that, and who's paying for it.
Yeah, definitely. And that all goes down to that wonderful skill that we definitely do all have, right, of requirements gathering. Because if you don't know what the requirements are, then you don't know whether you've satisfied them, right?
Yeah, exactly.
And I feel like that's a skill that like devs and BAs and clients and everyone needs to have. What do I actually need? Or indeed, what do they actually need, right? And it's a non-trivial task, right? Because it all revolves around communication and empathy, right? And I think those are the two hardest things to get right in development. Because, there's that stereotype of we're all nerds and we all hate people and we all like sitting in our little cubicles, put the hoodie up to block out the world, put the soundproof headphones on and just sit there and just hack away. But, we're a lot more complex. Well, I'd like to think that we're a lot more complex than that. But whether we are or not, we still have to deal with other people, right? And being able to communicate and get what is it that you want me to do, right? At the end of the day, that is what we solve the problem, but we need to know what the problem is to solve.
Yeah, and finding that problem is quite often hard, because you get this system where you ask somebody, what is it the problem that you've got, and they start, typically you'll get effectively a solution. So I suppose it's sort of the same thing as when you go to the doctor, isn't it? You're like, what's wrong with you? So, I don't know what's wrong with me. That's why I'm here.
My arm hurts when I do this. Well, don't do that
then. But yeah, I mean, it's kind of human nature, isn't it? So if you've got a problem, you kind of try and solve it, and then you extend that, but it might be that you're actually solving a problem that you don't have, or you've identified a problem as being a problem that doesn't exist. And that's a really, we have job titles that people's job is specifically to sort of tease that out, business analyst or whatever, to try and work out exactly what it is that somebody wants, and whether or not what they're asking for makes sense for the problem they've got. I mean, it's the faster horses thing, in it. So Henry Ford said, if I'd have asked my customers what they wanted, they'd have told me they wanted faster horses.
Yep. And that's why I always start, if I'm dealing with, a new client, new customer, new user, I say to them, go build me a spreadsheet that does what you want it to do. Like, it's almost like I'm asking them to prove that there's a problem, but it's more a case of, show me how it works, right? Show me the process, because we can both talk spreadsheet, right? So go build me a spreadsheet, and then we can talk spreadsheet together about, the charts that you want and the data you need to take in, and the special little formula that you don't realize you're applying, that are like, you'll say to me it's magic numbers, and to me it's magic numbers, but to you it really means something. And so build me that spreadsheet, or walk me through a physical, like you said, right? At what point does this physical activity need to be computed? walk me through the physical activity of, you writing your to-do list or you writing a report or whatever. Walk me through that, and then I'll be able to extract from that the things that I can digitize or that I can programmatically do for you. And then we'll both be at that better stage. And I feel like it's a little bit, I mentioned it earlier on, and it wasn't to make fun of it or anything, but I think that's what DDD really solves. It's like, talk to me in your language, and I'll talk to you in your language, and we'll just sort it out, right? Because it's I often find that it's speaking in metaphors and acronyms and things like that. That's where the requirements get muddy, I think. At least in my opinion, anyway. Maybe I'm hanging around with the wrong kind of customers. I don't know.
Yeah, I used to work in a place that did sort of gambling software, and a lot of that stuff was. It takes a while to get your head around it. I mean, there's bet types that I'm sort of a seasoned gambler, if you like. I do a bit of gambling, and I have done most of my life. But there's bet types like you can obviously the bookies want you to be able to bet on something even if it's a foregone conclusion. So I don't know anything about football really, but if like Manchester United are playing like Yeovil Town or something, they have various types of handicaps. So they have like European handicap and Asian handicap and all this, and the rules are really, really complicated. And trying to sort of translate that into basically first into English, because it's like it's a series of like basically complicated maths, and then translating into code is quite an interesting task. So yeah, see what you mean about the sort of ubiquitous language.
Yeah, and I feel like that'll help. Like, my personal opinion is DDD and ubiquitous language is a wonderful thing. It's I feel like it's more important than most of the principles like solid and stuff. I've made fun of solid a lot, right, in this episode, but I genuinely feel like the way we deal with humans is probably more important, or slightly more important, than the way that we do the minutiae of the individual lines of code. Because like I'm being super vague. I'm saying I'm saying I'm saying kind of, I'm saying that a lot, right? Whereas if you wanted to try and take what I've said and digitize it, you can't, because I'm fumbling around and not finding the right words. But if we're speaking the same ubiquitous language, we're speaking the language of the business, it's not easy to start with, but it starts to become super trivial. Instead of talking about null reference exceptions and packages that are missing and build pipelines that are failing, you start to communicate with the client or user or whoever in the language they understand. It's broke. I need to go fix it, right? They don't care about how it's broke. They just care that it's broke.
Yeah, exactly. It's broke, make it less broke.
Yeah, right. And that's me greatly reducing DDD down to like the smallest thing, right? It's so much more than that, but that's like the core nugget. And I think that's what's so important about like requirements gathering. I like the idea that you've said that for each section or each chapter of the book, there's a problem. And I mean, you have to do the vanilla ice bit. There's a problem and you've got to go solve it, right? I may have just been spending 50 minutes moving all the way up to that point. I do apologize. But like, are these the ways to solve those problems? Event-driven architecture, event sourcing, and distributed transactions, or are these just you've thought of these problems and they could be solved with these different architectures? Like, are there other architectures in the book, or are you just sort of focusing on these?
Yeah, so what I've done is basically add a list of potential sort of avenues that you could go down. And obviously that's not an exhaustive list because there's hundreds. So I start off with how would you solve this manually, just to try and do the requirements gathering bit. What exactly is it that we're trying to do, and how would you do it? And then I go, okay, well, we could use this technology or we could use that technology, and how would that work? Let's talk that through a bit. And a couple of times, obviously intentionally, I kind of go down a dead end to sort of discuss a piece of technology. I thought, I want to get this in. So would this work in this situation? Well, it probably wouldn't. But let's talk it through and see why it wouldn't. But would part of it work, or could it be adapted, and so on and so forth? So, that's basically the idea, to sort of just play it through in the same way as you would. I've worked with some pretty talented solutions architects in sort of recent years, and the sort of the way that they would analyze it, and that I suppose that job title gives you a bit of space, I suppose, because if you're your average sort of software engineer, and somebody says, okay, here's a system, build a system, what you're essentially doing is you're architecting the system as you go in it. If you think about that in sort of building a house scenario, which I come back to quite frequently, it'd be essentially delivering a load of bricks to a brickie and going, all right, okay, start building the house, but while you're building it, where are the windows going to be? Decide that, and work out where the door is, and the what are they called, the lintels, all that kind of stuff. What's load bearing. I don't know much about architecture, like physical architecture, so a lot of this I'm just saying words. But the point is that everyone would think that was ridiculous, but don't necessarily think it's ridiculous when you're dealing with a software engineer. So quite often you'll give a software engineer, and in some cases quite a junior software engineer, a system to write, and kind of just start writing code, just start typing. And you'll get some in the same way as if you give a brick here a big pile of bricks and say build me a house, you'll get something. Might not be the thing you want, but
No, I agree. You need to you do need to sit and plan it out, right? Because if you're exactly like you said, if you're building a house, you don't just start laying bricks and just let the chips fall where they may. You have to plan it out. You have to figure out how you're going to get the gas piped in, the water piped in, where the electricity is going to come from. And that's even before you start architecting the actual house, right? It's got all of these resources coming in, and then you can start. I'm really reducing physical architecture here, but you can start then drawing pictures of what you want the house to look like and translating that into a technical drawing. And without that technical drawing, I very much doubt that there are many construction companies who'll come anywhere near you. They won't go near you unless you've got an actual, right, we've got an architect, we've got a technical drawing, we've got everything written out to spec, we've got a budget, we've got all that stuff. But like you say, some engineers are just like, great, you want me to build right? I've already done file new project, right? Whilst you've been saying we've picked you for this new project. What am I building? You building it? Brilliant. I've already started. You know what I mean? It's like,
yeah. And I suppose I suppose the thing is, it doesn't, unlike, obviously I found this out because the room that I'm sat in at the minute was an extension, so we had to get a technical architect. Obviously a builder will not turn up unless you've got plans and so on and so forth. That's not true in software, and I don't think you necessarily need somebody whose job title is software architect, but you do need somebody who plays that role, if not as that job title. And it might only be back of a
envelope,
box cylinder, but it's worth at least making that decision. I'm a big fan of things like architectural decision records for that reason, because partly for that reason, partly because I've got the worst memory in the world. So I might decide to do something in a project, and by the time I've finished the project, somebody says, "Why did you do it like that?" And I can't remember. But if you write it down in an architectural decision record, then and I suppose for anyone who's listening who doesn't know, an architectural decision record is basically most of the time it's just a markdown file in your solution, and you just write, I have decided to do this. I could have done this other thing, but I didn't. The reason that I did this and not the other thing was this, and then you just date it and save it in your project, and then the next person who comes along can see that you've sort of written down that I've explicitly thought about my decision to use Entity Framework over Dapper, or I've explicitly thought about the fact that I'm using C# over Python, or whatever decisions you make while you're writing your project. You just basically write them down and keep them with your code so that people can sort of see that. And then if, like me, you've got a memory like a sort of goldfish, then by the time it comes to somebody saying, oh, okay, why did you do this? Then you don't, even that question doesn't need to be asked because it's kind of self-documented.
So I like that idea, because there's been so many projects over the last maybe 2 or 3 years that I've worked on where I walk into the code base and go, ooh, what the? And before I even start thinking, oh my goodness, this is terrible code, my immediate thought is, right, I need to try and figure out what the original developers were thinking when they did this. Not as a negative, what were they thinking? More like, right, what paths did they go down and why did they consider doing this? So then I can understand why it's written this way. And I like this idea of having this sort of living documentation with your app, where you say, look, I've thought about doing it this way, I've thought about doing it that way, and this is the only way that really makes sense given the constraints we have right now. And I feel like that's the important bit, the right now bit. Right?
Yeah, and there's no right and wrong to any of this, is there? It's like, it's not like, I'm gonna say it's not like maths, and I'm sure that somebody who understands maths better than I do will correct me on this. But in maths, there's like one way of solving a problem, and so if you get two numbers and you need to add them together, and I'm sure this isn't true when you get a bit more advanced with maths, but I'm going to say it anyway. If you've got two numbers, you've got 2 and 3, and you're adding them up, then that's always going to be 5. But that's not true with software, because it might be that there's 3 or 4 different ways of doing something, and they might be equally valid. What matters, I suppose, is that you thought about it, not that you made the doing the inverted commas thing again, right decision. It just matters that you thought about it, and most I suppose the time that it's frustrating of reading someone's code is when you kind of think, well, that wasn't even considered. If you can see it's been considered and somebody wrote, well, I decided not to do it because of this reason, it's kind of fair cop, isn't it? I mean, the worst thing about what you just said is when you look at that code and you think, oof, and then you do a git log and you think, oh, it was me.
Yeah. Yep. I've done that way too many times. Oh, goodness, why did I write it this way? And that's why I tell people, like I tell juniors and mentees, that the person you were yesterday, at least in an engineering context, is a completely different person. You're not just leaving comments for other people who work on the code. You're leaving comments or you're leaving documentation for yourself, right? Because you tomorrow are going to be different to you today. Because tomorrow you won't have all of the context of why you've just made this decision right now, right? You'll just have, oh, I made that decision yesterday, or some idiot made this, oh, right, it was me,
Yeah.
But yeah, oh my goodness. Okay, so Paul, where's the best place for people to find out more about you, and indeed for them to get the book? Is it you just go to Amazon and type in Paul Michaels software architecture and it comes up?
Yeah, pretty much. So to find out about me, I'm on Twitter, Paul_Michaels. I blog at pmichaels.net. The book in question is called Software Architecture by Example. And I hope that if you type that into Amazon, it would come up in the top few results. But who knows? I'm guessing you've got some show notes with this, so I'll send you a link to it, and yeah, you can link to it. Yeah, that's probably the best way of getting in touch with me. Either of them avenues.
Cool. Okay. Awesome. Well, thanks for being on the show, Paul. I really appreciate you being on again. And well, I mean, best of luck with this new book. And maybe there's another couple of books in you. I don't know. You said at the beginning you've always wanted to be a fiction writer. Maybe now's your time to write a fictional tale of architecture gone wrong. Software architecture.
Yeah. Thanks for having me again. Yeah. I mean, I think I've said it last time, but I think this is probably the last technical book that I'll write. But I did say that last time, so maybe it won't be. But yeah, I would quite like to come back and talk to you about my best-selling fiction novel when I write it. But that might be in 10 years' time.
I mean, why don't you write? Title your next one, "The Last Technical Book I Ever Write" by Paul Michaels, and then the one after that, then this is really the last one, Honest, and then you've got the beginnings of a trilogy, right?
Or was this like was it the Eagles did the Hell Freezes Over tour? Because they said when we get back together, and they said when Hell Freezes Over, and then they got back together and did the Hell Freezes Over tour.
Oh, right, is it? Or perhaps the Rolling Stones with their "We Are Retiring" tours, like all of them.
Yeah, every couple of years, yeah.
Yeah, awesome. Well, like I said, Paul, thank you ever so much, and it's been great catching up with you.
Thank you. Cheers.
That was my interview with Paul Michaels. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .netcore.show/review for ways to do that, or to reach out via our contact page, which can be found at .netcore.show/contact. And to come back next time for more .NET goodness. I'll see you again real soon. See you later, folks. .NET Core Podcast is a production of RJJ Software Limited.